So today we are talking about volume, or loudness, in other words. Let me get some real quick. Let's try that again. What was the difference between those consecutive notes that I was playing? It's not the pitch. The pitch of those notes is the same because I kept my finger in the same place over here. So the note I played was the same. The frequency you heard was the same too. The difference between those two is the volume, how loud they are, okay? So the loudness, or the volume, of a sound wave corresponds to its energy, okay? If I hit the string harder using more of my energy, then I produce a more energetic sound wave. If something is too loud, it could hurt your eardrums. It can actually make them bleed if you think about putting your ear up to I guess we've all experienced a fire drill so far, right? So with the fire drill, that's a high energy sound. It's loud. High energy means it could hurt. And it's measured in our drawings by the amplitude of the wave, the height of the wave. Think about a tidal wave, a very high energy, a tall wave, okay? Could cause destruction, all right? It's a high amplitude wave. Okay, so the unit of volume is decibels. You might have heard of that before if they have like a sound meter at a sports arena. Remember when we used to have sporting events? And yeah, decibels, right? So you want to, with your ears, with headphones, keep the decibels low. Don't hurt your ears. All right? Okay, so last video we drew waves that had the same volume but different pitches. Now we're going to do same pitch but different volume, all right? Same pitch, different volume or loudness, okay? I realized we forgot that. So we switched the same and the different words there, okay? So here's a quiet wave, low volume, and here's a loud wave. All right? But these play the same note, just like I did on the guitar. Why is this one louder? Well, look at the measurement of amplitude with the red line over here versus the measurement of amplitude over here. This one is twice as loud, twice as tall of a wave. But how could you say that they have the same pitch? They look different, but they play the same note? Just one louder than the other? Do, do, same note. Because the note is the frequency. So these have the same, that's not a good marker, same frequency. What would make it look like a different pitch or frequency is if we took this wave and instead of making it taller, we made it more squish or stretched. But all we did from this picture to this picture was make it taller, which made it louder, but not higher pitched. This going to this picture, this would get higher pitched if we did the, we squished it like that and we made something like that. You don't need to draw this. That would be very high pitch, okay? But this did not do that. It had the same wavelength, the same length from one wave to the other, so it had the same frequency as well.